See, last class we discussed about the difference between or comparison between the petrol and diesel engine, and already you have studied the differences between the petrol and diesel engine. That's nothing but two-stroke and four-stroke engines. You have two-stroke as well as four-stroke in both type of engines, petrol and diesel engines. So you already studied the difference between or comparison between petrol and diesel engine. Next, come to the point, very important. That is very important. Few definitions which are very important for the problems. So in this chapter, you have problem. In that, you have to calculate few factors. One is a thermal efficiency, BHP, brake horsepower efficiency. Like that, you have to calculate so many factors in the engine. So in the first one is specific fuel consumption. Specific fuel consumption. Say the specific fuel consumption, that's called as the SFC, that is nothing but the unit of energy produced. The unit of energy produced. The unit of energy produced. That is 1 unit of energy produced is called specific fuel consumption. For that, how much amount of fuel is consumed? How much amount of fuel is consumed? So that is nothing but the specific fuel consumption. Say the specific fuel consumption are very high in diesel engines, that is less in petrol engines. Remember all of you, the unit of specific fuel consumption is kg per megajoules or kg per watt hour, kg per watt hour. So that is the kg per megajoules. See, usually the diesel engines have the compression ratio 16 is to 1 or 20 is to 1, and the petrol engines 7 is to 1 and 12 is to 1. That is the unit of energy, 1 unit of energy produced. For that, how much of fuel is consumed? That is called specific fuel consumption. Next, come to the point, very important, the calculations used in engine. Calculations used in engine. See, all of you observe here, the very first indicated power. Indicated power. So what is the indicated power? That is a mean effective pressure. The mean effective pressure, use mean effective pressure, that is in newtons per meter square. For that, you have the equation, that is indicated power, lowercase p equal to SA divided by L. That is, S is the spring value of spring used in the indicator, that is in newtons per meter square per centimeter, and the area of actual indicator diagram, that is in centimeter square. L is the base width of the indicator diagram, that is in centimeter. Say, all of you observe here. Here everything is in meter and centimeter. Meter and centimeter. Next, all of you observe here the indicated power in case of four-stroke engine. How do you calculate the indicated power in case of four-stroke engine? That is PM equal to mean effective pressure, that's in Newton meter square, L, length of the stroke, that is in meters, and A is the area of cross section of the cylinder, that is in square meter, and N is the RPM of the crankshaft. Lowercase letter n is the number of cycles per minute. To use these concepts and substitute in the equation, mean force acting on the piston multiplied by piston displacement in one stroke, that is in L, that's in Newton meters, PM into A. Substitute all the values here. You will get the indicated power of a four-stroke engine. Next, work produced by the piston per minute. Again, it is work produced by the piston per cycle into number of cycles per minute. That is PM into L into A into N. That is very, very important. Number of cycles per minute. That is totally PM LAN, Newton per meter square. That is the in IC engines, the two in four-stroke engine, that is the piston completes the cycle in two stroke. That is indicated power. So all of you observe here, very, very important, and all of you write down the indicated power for four-stroke engine. Indicated power four-stroke engine. Below that, write down. Below that, write down indicated power equal to PM LAN divided by 60 into 2 into 1000 kilowatts. Four-stroke engine. Next, the PM indicated power when PM is expressed in bar. That's the pressure that is in bar. The indicated power of a four-stroke engine is equal to 100 into PM LAN divided by 60 into 2. If for four-stroke engine, remember all of you, the piston movement is 2 times. For that reason, this is 2 indicated power. All of you understand while solving the problem. In the later classes, you have to solve the problem. So the problems are direct one. You have to substitute the values of L, A, N, PM. Next, come to the point. Say indicated power in case of two-stroke engine. All of you observe here. The N is equal to 2 in case of four-stroke engine. Here, the N value is equal to the number of cycles. For that reason, N equal to 10. That is, PM is expressed in newtons per meter square. Power of a two-stroke engine is given by indicated power equal to PM LAN by 60 into 1000. Suppose if you want to express the PM that is in bar, then the equation indicated power equal to 100 into PM LAN divided by 60 kilowatts. Next, come to the point. Very, very important. Almost all the question paper, you have to calculate brake horsepower. Brake horsepower. That is, all of you seen the braking system in the two-wheeler or the braking system in the four-wheeler. How much power is lost? That is the friction. The friction, the vehicle running in a particular speed, due to that dynamic brakes presses the wheel, then the wheel comes to the standstill condition or stop condition. In this case, the friction is very, very important. Due to that friction only, you can calculate the brake horsepower. Brake horsepower. See how you are going to stop the running of the crankshaft by using braking system. This is also called friction power. This is also called friction power. That is, the friction power equal to indicated power minus brake power. All of you observe here. The friction power equal to indicated power minus brake power. The brake power is calculated from the equation. All of you observe here. W equal to net load acting on the brake drum. Say W, the net load acting on the brake drum by applying the brake using shoes, brake shoes, brake shoes, that is in kgs. Next, R is the radius of the brake drum, radius of the brake drum, that is in meters, that is in meters. And next come to the point, N, RPM of the crankshaft, RPM of the crankshaft. Next, T, torque applied due to the net load W on the brake drum. That is very, very important. The torque applied due to the net load W on the brake drum. See, this is a particular load. For that, how much torque is produced? That is in kg, that is in kilonewtons meter. That's in kilonewtons meter. That is W into R. W is the net load and R is the radius of the brake drum. So all of you know the definition of the torque, the load into perpendicular distance. Load into perpendicular distance. Load is W and the perpendicular distances are. Therefore, torque T equal to 9.81 divided by 1000 into W into R, kilonewtons meter. Kilonewtons meter. And brake power can be calculated. Say you have the torque T, substitute here. That's N is the rough RPM of the crankshaft. That's in kilowatts. You can calculate the brake power by using the relation. Before calculating brake power, calculate the torque. All of you understand while solving this problem. Next, very, very important, the mechanical efficiency. Almost all the problem you have a concept of mechanical efficiency. So this is the efficiency. This you can define like this: the energy input to the engine and what is the output from the engine. So this is the ratio of input to the engine and to the output of the engine. That is, you can define like this: mechanical efficiency is nothing but the input to the engine, ratio of input to the engine to the output of the engine. That is mechanical efficiency represented by eta equal to brake power divided by indicated power into 100. The indicated power is nothing but input to the engine, and the brake power you are calculated. See here, this is the brake power 2 pi nt divided by 60 in kilowatts. The same thing, brake power, substitute here. The indicated power we have already calculated here. The indicated power for two-stroke engine and the four-stroke engine, PMLAN divided by 60 into 2 in case of four-stroke engine. In case of two-stroke, 1000 into 100 into PMLN divided by 60 in kilowatt indicated power. So before that, friction power or brake power. See, brake power, for that you have equation 2 pi nt divided by 60, that's in kilowatt. Next come to the point, the mechanical efficiency, that is the ratio of input to the engine to the output of the engine. Input is the indicated power and the output is brake power multiplied by 100. That is the indicated brake power can be calculated by using indicated power minus friction power divided by indicated power into 100, or you can calculate directly brake power divided by brake power plus friction power. So using this relation also you can calculate the mechanical efficiency. Which one is easier, that you can use it for calculation purpose. Next, almost all the engines you have to calculate the thermal efficiency. Thermal efficiency of the engine. This is nothing but the heat supplied to the engine. What is the heat output of the engine? That is the time interval input to the output. That is thermal efficiency, the heat produced by the engine. That is nothing but power output of the engine. The heat, thermal efficiency, that is the efficiency of the engine. What the power produced by the engine, that is the heat produced by the engine, by using relation thermal efficiency, eta thermal equal to power output divided by heat energy supplied by the fuel. Say, burning of 1 unit of petrol or 1 unit of diesel, how much energy developed to the engine, to the output. All of you observe here, once again, the efficiency is input to the engine and the output to the engine. That is the ratio of input to the engine to the output of the engine. Multiply by 100, that gives you the thermal efficiency. Next, that is brake thermal efficiency. Almost all the problem you have this question. Calculate the brake thermal efficiency of the 2-stroke petrol engine or 4-stroke diesel engine or 4-stroke petrol engine. The brake thermal efficiency, that is eta B thermal. See, the unit that is the represented by eta B thermal equal to, you have already know that brake power divided by heat energy supplied by the fuel into 100. Eta B thermal equal to Bp divided by Cv into M multiplied by 100. From this you can calculate the brake thermal efficiency. Then where M is the mass of the fuel supplied. Remember, the mass of the fuel supplied, that is in kgs per second. Kgs, that is mass of the fuel supplied, kgs per second. Next, calorific value of the fuel. Say you have a separate calorific value for petrol and diesel represented by kilojoules per kg. And the brake power. So previous step, you have calculated the brake power in case of 2-stroke engine and 4-stroke engine, that is in kilowatts. That is in kilowatts. Next, almost all the problem you have to calculate the indicated thermal efficiency. Indicated, remember the indicated thermal efficiency, that is eta I thermal equal to indicated power divided by heat energy supplied by the fuel. Say the heat energy burning of 1 unit of fuel, how much energy is supplied to the engine, that is the indicated thermal efficiency is defined as, that is the ratio of input, that is the heat energy supplied by the fuel to the indicated power multiplied by 100. That gives you the thermal, that gives you the indicated thermal efficiency, that is eta I thermal equal to Ip indicated power divided by Cv into M multiplied by M multiplied by M multiplied by M. Next, come to the point. all of you write down the question. All of you write down the problem. So if you write this problem, today itself, I will finish off this engine chapter. Next class, I will start the new chapter, refrigeration and air conditioning. All of you write down the problem. A single cylinder, two-stroke cycle. Remember, problem number 1, a single cylinder, two-stroke cycle IC engine has a piston diameter 105 millimeter, 105 millimeter and stroke length 120 millimeter. The mean effective pressure is 6 bar. Mean effective pressure is 6 bar. If the crankshaft speed is 1500 rpm, calculate the indicated power of the engine. All of you write down. That's the single cylinder, two strokes IC engine, piston diameter 105 millimeter, stroke length 120 millimeter, effective pressure 6 bar, and the speed of the crankshaft is 1500 rpm, and calculate the indicated power of the engine. Say from 1999, remember till today, the same problem repeated many times in your question paper. Many times in your question paper. Below that, write down solution. Below that, write down solution. That is first diameter of the piston, uppercase letter D equal to 105 millimeter, and the stroke length, uppercase letter L equal to 120 millimeter. The mean effective pressure PM equal to 6 bar. Mean effective pressure is 6 bar, and the speed of the crankshaft 1500 rpm. This is the two-stroke engine. For that reason, N equal to N. In case of four-stroke engine, N equal to 2. Here, N equal to N because of two-stroke. Then the equation is available. That's the indicated power of two-stroke engine. All of you open the calculator and substitute the values in this equation. IP equal to 100. This is the equation available for calculation of indicated power. Indicated power IP equal to 100 PMLAN divided by 60 into, that's in kilowatts. Say all of you substitute the values of the values available in the problem. IP equal to 100 PMLAN divided by 60. Say 100 is as it is. Pressure, mean effective pressure is 6. The stroke length is in millimeter. Convert that into meter, 0.12, and 5 into 105 square. That is PMLAN. That's the area of the piston. Say diameter you have. Convert that into area of the piston or area of the cylinder. Pi d square by 4. That is area of the, or otherwise put a right side margin. Area equal to pi d square by 4. Pi into, that is the diameter of the piston is 105. Convert millimeter into meter. Then pi into 0.015 whole square into 1500. N is the RPM of the crankshaft divided by 60, and this is the pi d square by 4. Calculate the indicated power in this problem is 15.58 kilowatts. Indicated power in this problem is 15.58. Next, come to the point. One more problem. All of you write down a four-stroke IC engine. All of you write down a four-stroke IC engine running at 450 rpm. Running at 450 rpm, has a bore diameter of 100 millimeter. All of you write down. A 4-stroke IC engine running at 450 RPM has a bore diameter 100 mm and a stroke length 120 millimeter. All of you open your calculator and write down the questions, write down the problem in the notebook. And next, continue the problem. The indicator diagram details are: area of the diagram is 4 centimeters square. Length of the indicator diagram is 6.5 centimeter. And the spring value of the spring used is 10 bar per centimeter. 10 bar centimeter. Calculate the indicated power of the engine. Calculate the indicated power of the engine. Below that, write down solution. That is, the engine is running at the speed, that's the crankshaft of the engine running at n equal to 440 rpm. That's the bore diameter d equal to 100 millimeter, and that is the indicated diagram. That is, the area of the diagram is 4 centimeter square, and the length of the indicator diagram, that is 120 millimeter. Stroke length L equal to 120 millimeter. Small letter, that is the length of the indicator diagram, is 6.5 centimeter. S, that's the pressure of the spring, that's S equal to 10 bar per centimeter. Say you have the indicated power of a 2-stroke engine, that is given by mean effective pressure PM equal to SA divided by L. So you have the value. S is 10 and A is 4 and L is 6.5. You have the mean effective pressure PM 6.15 bar. Next, come to the point. Indicated power of the, say, this is the 4-stroke engine, N equal to 2. That is IP equal to 100 PM LAN divided by 60. 100 as it is. You have calculated the mean effective pressure 6.15. L is 120, that is 0.12, and pi d square by 4. Pi d square by 4. Instead of writing, say, n equal to 4, pi d square by 4, this becomes 2. Here, you divide the 4 by 2, you will get 2 here. And the speed of the crankshaft is 450 millimeter, and 4 as it is 60 into 2. So indicated power, that is 2.17 kilowatt. 2.17 kilowatt. So all of you write down indicated power IP equal to PM LAN divided by 60. That is 100 as it is. Mean effective pressure 6.15. Stroke length 120 millimeter. Further to the 0.12. Pi d square by 4. That is the area of the cylinder, and the crankshaft is running at 450 rpm and divided by 2. That is the stroke length of, that's the 4-stroke engine, N equal to 2. N equal to 2. So if you substitute all the values here in this equation, you will get 2.17 kilowatt. Next, this is the direct problem. This is, write down all of you the question. 2-stroke internal combustion engine has a stroke length of 150 mm and the cylinder diameter is 100 millimeter. Mean effective pressure is 5.4 into 10 to the power of 5 newtons meter square, and the crankshaft speed is 1000. Find the indicated power. All of you write down the problem. A 2-stroke internal combustion engine has a stroke length of 150 millimeter and the cylinder diameter 100 mm. Its mean effective pressure is 5.4 into 10 to the power of 5 newtons meter square, and the crankshaft speed is 1000. Find the indicated power. Write down solution. Below that, write down L equal to 150 mm. Stroke length of the piston is 150 millimeter, and the bore diameter is 100 millimeter. Mean effective pressure 5.4 pm equal to 5.4 into 10 to the power of 5 Newton meter square. N equal to speed of the crankshaft is 1000 rpm. The indicated power of the two-stroke engine is given by, you have the equation IP equal to PM LAN divided by 60 into 1000 kilowatts. Say mean effective pressure, that is 5.4 into 10 to the power of 5, and L is the convert millimeter into meter, that's 0.15. Area of the cylinder pi d square by 4 and 2000 divided by 60 into 1000. So from this, calculate the indicated power after substituting all the values available in the problem. In this problem, you have the answer 10.6 kilowatts. 10.6 kilowatts. 10.6 kilowatts. This completes the IC engine. Next class, I will start the new chapter, refrigeration and air conditioning. Today, you have studied the 3 problems. So in my notes, you have more than 10 problems are there. You can calculate the values, indicated power and brake horsepower, thermal efficiency, torque. So in problems of IC engines, everything is direct. Only thing is you have to remember the equation. Remember the equation. So you have solved the 3 problems in this class. In the same way, you have more than 10 problems in the notes. Solve the problem and remember the equation. Remember the equation. That's the very important. So this is the last concept in IC engine. Today I stop at this stage. Now I make unmute to all. If you have any questions regarding IC engines, please ask me. Harshita, can you listen?
Yes.
Sampath, can you listen? Rahul, can you listen? Maitreyi, can you listen? Maitreyi, I will send you the notes for. I will send you the notes. Huh?
Yes, sir.
Maitreyi, can you listen?
Yes, sir.
After 12 o'clock, I will send you the notes through email ID. Huh? Okay,
sir.
You can start, you can circulate and also you can refer that. The notes.
Okay, sir.
Okay. Now I stop at this stage and I'll continue in the next class.
Okay, sir.